The following presentation was recorded live at SOA Software's Breakfast of SOA Champions educational series. If you have questions or comments, please contact us at info@soa.com.
So what I got is a set of diagrams that sort of show a set of mythical enterprise applications, some example applications that may exist, sort of focused on a financial services example, and it's actually based on one of our customers. So the sort of environment you may have, a bunch of commercial off-the-shelf applications like SAP, Siebel, the Oracle application suite, all those sorts of things. I like the interactive lighting effects, by the way. Thank you. Keeps me on my toes. Then some applications that are likely to have been built in-house. And in fact, one of the reasons why SOA has been more strongly adopted inside financial services organizations than inside many other organizations is that financial services tends to have a higher weighting towards homegrown applications and things that you guys build yourselves. And that's primarily because, as the folks at Merrill Lynch call it, they're not really a financial services company, they're an IT company on steroids. Financial services businesses are driven by the technology that runs those organizations for the most part. So if you look at this infrastructure and forget about these bits initially, you have a set of applications running through the organization. They're large monolithic chunks. They're built independently. There's an awful lot of stuff inside those applications that they have in common. It's not shared, but they have it in common. So every single one of these applications has some kind of authentication mechanism built into it. Almost all of them have some kind of database. Most of them do something to do with customers, so have some kind of data store where they store and manage information about those customers. That stuff all ties together. Just flip to the next slide. So one of the first steps that organizations have gone through, and most organizations have already started down this path, is to move towards a more componentized architecture, where you take these large monolithic applications and you break them down into pieces. Object-oriented programming, Corva, those types of things are the models that have driven people down this component architecture type path. And what that allows you to do is start to see your applications in terms of the pieces that make them up. Okay. So I'm to back up. What is SOA? Let's start there. Service-oriented architecture. It is a way of thinking. In fact, you know what? I'm going to keep going because this sort of explains it. Okay. So in terms of the applications, you break things up into components. Each of these components are business elements. They're simple pieces of business logic that are built together to form an application. So something like a customer database, something like an authentication mechanism. That's how do you control who gets access to the application. Some business logic that's specific to a particular application. There's a lot of bits in here that all these applications will have, but they'll all have built them together. Next slide, if you would. So this is where we start to introduce the concept of services. Now, a service is when you take one of these pieces of business logic and you expose it with a set of standards-based interfaces. So now you've got a piece of business logic that's addressable not just by one application, but by any other application that chooses to call it. So to give you an example of a good example of a typical service, think about foreign exchange conversion. A lot of financial services applications are going to have an internal function that's built to handle Forex transactions, just straight up currency conversion. Now, it doesn't make sense to have every single application everywhere through your organization do its own currency conversion. As much as anything, you're going to get inaccuracies and differences between the different applications. You need a single application somewhere that handles that currency conversion for you, and that application should be exposed as a service. And this is where you start to get towards the concept of service-oriented architecture, where you find all the things that you have in common through your applications, you pull them out, you create a library of them, or a registry, and you expose standards interfaces from each of these services. So now let's take an example from here, in a stock trading environment, you get current price. The get current price service exists in your Forex trading application. You expose that as standard services, then whenever any other application or a new application you're building happens to need a get current price transaction, it can go call it from this environment here. It doesn't have to build its own. So the idea of service-oriented architecture is that you share common components between all of your applications. And the value of doing that is what the SOA guys call reuse. So you're trying to reuse technology from one application and use it again in others, and again and again and again. The sort of the most public example from a business that I can think of is Verizon. Verizon went through a whole series of big press announcements last year around April when they started talking about their SOA infrastructure projects. Now what Verizon did in about early 2003, late 2002, they looked at their organization. As you may recall, Verizon was a merger of GTE and Bell Atlantic. They looked at the organization, they looked at their IT spend, which was somewhere in the $8 billion a year range, and they looked at that and said, well, this is ridiculous. We can't possibly be spending this much money in IT. Why are we spending so much? They looked around a little and they realized that they had at least two of everything. In some cases, they had as many as 200 different instances of the same thing, whatever that thing may be. So their CIO, a chap called Shigon, appointed a chief architect, a guy called Shadman Zafar, and he set Shadman off with a very clear mission. He said, your goal is to move us towards service-oriented architecture to drive reuse. And you're going to drive reuse to cut my costs in IT. I want to be spending half of what I'm spending today within 2 years. And we're going to do that by adopting SOA and moving towards reuse. Extremely aggressive goals, really probably attributing a little too much benefit to SOA and not quite enough to natural consolidation after the merger. But basically what Verizon did was they set up a whole bunch of processes and procedures internally, as well as some technology, and they set goals for every manager within their IT organization. So every manager in the organization has a reuse goal. They have to demonstrate that their organization is driving reuse in one way or another. They set up an architecture review board. So if you're an architect creating a new application, you take your design for the application to the architecture review board. That board is going to look it over and say, yeah, we like it, this is great, this is great. You know, this bit here, we've already got one of those, and this bit here, we've already got one of those. So you're not going to build those. You're going to reuse them. You get that's .NET, and I'm in Java. I don't want to use that .NET stuff. But Verizon just laid down the law and said, no, that's the way it's going to be. You are going to reuse existing services. And if you don't, then you're going to miss out on your bonuses because you'll fail to meet your reuse objective. So in order to help all this stuff work, Verizon also recognized that it needed to provide some kind of infrastructure for facilitating reuse. We're going to talk about what that infrastructure is a little bit later and why you need it. And let's move on to the next slide. So the ROI for service-oriented architecture and web services in particular, and I'll come back in a minute to talk about web services. The ROI for SOA is quite simple. It's driven by reuse. You're trying to share services in one application, share services exposed from one application inside others. So I mean, this is a little bit of a crass example, quite deliberately. Let's say that you choose one of your applications that has a particularly good login function, and you say, well, you know what, I really like this login function. I'm going to use it in all my other applications. So instead of building a piece of login functionality in your equity trading example, you say, I'm going to use Siebel's login routines. I'm going to share them over here, so this thing's not going to have to do its own login. It's going to be handled over here. And in fact, when you think about what's happening in enterprise IT and access management, that's really the direction we're moving in. You have platforms like CA's SiteMiner, the Netegrity product. You have Tivoli Access Manager driving web access management. You have products like Microsoft's Active Directory that a lot of enterprises are using for core identity management. So who are my users? What are their rights, basic rights and roles? You store all that stuff in Active Directory. So essentially, Active Directory is a shared service. That's a big change from even as recently as the mid-90s. In the mid-90s, every single application would have had its own local database, and that database would have contained information about every user of that application. You don't really have that anymore. You do it, we still do in some cases, but in the majority of cases, there's a central shared infrastructure for identity and access management. And that's one example of a service inside a service-oriented architecture. Now, it's not typically a web service, which is the standard that's driving the adoption of SOA. And in fact, to that point, SOA is really nothing new. CORBA, which is the whole component object request broker model from the late 80s and through the mid-90s, was an example of SOA. It failed. Well, failed maybe a strong term. It didn't succeed as wildly as its protagonist expected it to. And the main reason behind that was that it was not standards-based. It was very difficult to share an object in one application in another application. It would be almost impossible to share CORBA objects between an application that was built in .NET and an application that was built in C++ and an application that was built in Java. Really hard to do that with CORBA technologies. The reason why SOA is the huge buzzword in the industry today is because of a technology called web services. Web services is an absolutely awful name for a piece of technology. The reason it's an awful name is because it really has nothing to do with the web. Web service is what folks think of as the next generation of the internet. And again, that's sort of a misconception. A web service is really a very simple thing. It is a piece of business logic that has some defined standards-based interfaces. The reason it's tagged with the whole web thing is because it's XML-based, and XML is a W3C-driven standard. So it's sort of thought of in the same breath. But basically what we're saying is you take a piece of business logic and you define how other things, applications, not people, specifically how other applications will interact with that piece of business logic using a set of XML-based interfaces. So you define things like, well, where is this thing? Is it in a Java app server? Where can I find it on the network? How do I address it? So what URL structure do I use to talk to it? You define what type of methods does it have. So you might have a web service called account management, and it might have methods like get balance, transfer funds, withdraw funds, deposit funds, list accounts, that type of stuff. Those would be methods inside an operation. You define the parameters of each of those methods. It's very, very much like a programming model, but something that's at a much higher level of business granularity. And then you expose those interfaces using some kind of standard transport. Now, another reason why web services got the name web services is because initially they were available only over HTTP, so over the protocol that you use for web traffic. But instead of a browser connecting to a web server, you'd have an application connecting to an application using this web service. And there are some standards. There are things like WSDL, the Web Service Definition Language. That's how you define all those interfaces, how you define what the service is, where it lives. There's a protocol called SOAP, the Simple Object Access Protocol. And SOAP is really the common standard that really defines what is a web service today. Now, you're going to get a lot of argument. And there's a lot of folks out there who say, no, a web service is anything that does a little bit of XML. Other folks will be, no. Strictly speaking, a web service has to have all three legs, WSDL, SOAP, and the UDDI registry. The reality is the pragmatic approach to web services today says, if it talks SOAP, it's a web service. And SOAP is a nice, simple messaging technology, essentially. It's a way of wrapping up a business request, like list accounts, and defining a response. So you have an XML document that defines the input to this function, and an XML document that defines the output. So you define all your interfaces in very simple technology terms, and then you allow them to talk to each other. You define where they are. The third leg, WSDL and SOAP being the first two, is the registry. The registry is defined by a standard called UDDI, Universal Discovery and Description Index. I think that one I always get wrong. But UDDI really defines a directory. It's a place you publish all your services. So someone who is creating a new application, an architect at Verizon, who knows that he has a reuse goal, can look at the application, break it up into bits of logical business sort of stuff at a decent level of granularity and say, okay, I've got my get customer information piece here. I know that that's got to exist somewhere. So let me go look in my registry and try to find a service that I can consume. Finds it in the registry and then builds the interface into his application. So instead of having to build that whole customer database, he just interfaces to something that already exists. That is how you get reuse, and that's how you save money, basically. So SOA primarily is about saving money. It's a reuse-generating, cost-saving model. If you can move to the next slide. So really where you see the true return in SOA is when you build new applications, you don't have to build the whole thing. You only have to build half of it, because half of it already exists. You can find the bits that already exist in the registry, and you can use them. So from the context of a business organization, you can build applications faster, and you can build them for half the cost because you're using SOA. Now, the downside of that is that the first couple of projects will probably cost you more because you have to start building things as services rather than just as core part of the project.